Hello, welcome back to Algebra. Here we're going to continue, we're going to conclude our discussion of solving systems of equations by substitution. The process we're going to use to solve these problems is exactly what we have done in the previous sections. The only real wrinkle is that most of these problems will have fractions or other terms. In other words, turning the crank of the math and doing the fractional work and stuff is going to bog it down a little bit and make it seem harder. But the actual process is the same. So the only way you get good at this stuff is to practice. So let's go ahead and practice right now. Our very first set of equations looks like this. Let's say we have 3x plus 3y equals 6. That's equation number 1. And our second equation as part of our system is 5x minus 6y is equal to 15. 5x minus 6y is 15. So we have two equations. Now there's a million different ways we can go. We can solve for x and put it in here. We can solve for y here and put it in here. Or we could begin to work with this equation. We could solve for x and we can put it in here. Or we could solve for y and put it in here. There's 4 different ways right there that you can start the problem. So what we're going to do, just to pick one, is we're going to solve this equation for y. And then we're going to take that and we'll stick it into this equation here. And we'll go from there. So in order to do that, let's start solving this for y. Let's move the 3x to the other side. Once we subtract it, we'll just have 3y on the left, and there'll be negative 3x plus 6 on the right. So just subtract 3x here, subtract 3x from the right-hand side. All right, now to get y by itself, we'll divide by 3. So when you divide the right-hand side by 3, you're dividing everything by 3, which is the same as dividing each of these terms by 3. And I've told you that about 60 different times because it just makes it easier. You're dividing the left by 3, so it kills it. You're dividing the right by 3, the whole term, which is the same as dividing each term individually by 3. All right, so what you actually get for y is when you divide negative 3 divided by positive 3, you get negative 1, so it'll be negative 1x. And then over here you have 2. So you get y is equal to negative x plus 2 like this. So we've solved for y. So we're going to use our little arrow to indicate that we're coming up here and we're plugging this value in over here. So we're going to stick it in for y. So what we have is 5 times x minus 6 times y. Now, in order to plug in for y, we have to open up a bracket because y is equal to this entire term, negative x plus 2. Do not do too many things at once. Don't try to start multiplying this stuff out. You're just writing it as a multiplication, and then we have 15 on the right-hand side. Now, in the next step, we need to go through and start multiplying. Now, this is a negative 6 here. So when you multiply it through, it's negative 6 times this, negative 6 times this. So first we have the 5x, which stays along for the ride, 5x. What's negative 6 times negative x? Negative times negative is positive 6x. And then negative 6 times 2 is negative 12. Right? Negative times positive is negative. And on the right-hand side, we just have the 15. So far, so good. Now we have to clean terms up, and you can see that you have x's here. We'll be solving for x. So 5 plus 6 is going to give you 11 x's. And for now, let's just keep the 12 here along for the ride. But we know that we need to move the 12 over, so we'll add it. So we'll have 11x on the left. We add 12, it's going to disappear. And on the right, we're going to take 15 plus the 12. So we add 12, add 12. 15 plus 12 gives you 27. All we did was add 12 here and add 12 to the right. Now we'll be dividing by 11. So we'll have 27 over 11. And that's about as far as I can do the simplification on that. So what we've done is we've solved for y, we plugged it in. That means we eliminated y. Now we solved for x. This is the value of x as the actual answer. Now we can take this value of x, we can do lots of things with it. We could take this value of x and we could stick it into the original equation, and then we would be able to solve for y. Or we could take this value of x and we could put it into the other equation here, up here, and we could solve for y. Either way, you plug in for x, you're going to have a y variable that you can solve for. But it's actually just easier to take this value of x and stick it right back in this equation, because this equation came from the first one, and I've already done all of the math so that I'm basically saying y is equal to something. So I'm trying to find y, so I'll just plug in what I know x to be. It's a negative sign, x is 27 over 11, and then I have plus 2. So what I end up having is negative 27 over 11 plus 2. Let's write it as 2 over 1. Now here's where I say you get into issues with fractions. I need to add these fractions together. But I have 11 as a denominator and I have 1 as a denominator. That's why I wrote this as 2 over 1. So I need a common denominator. The easiest thing to do is just multiply this on the bottom by 11, which means I need to